an infinite series, or just series, is an infinite sum. That is, in general, we have to add infinite number of numbers. A0 plus A1 plus A2 plus A3 plus and so on. In general, if you want to use the sigma notation, we'll write down that this I in our case starts at 0 and ends in an infinite series is an infinite sum. Let's write down a few examples. For example, if I write 1 plus 1 plus 1 plus 1 plus 1, that is an example of infinite series, and it's kind of obvious that you have 1 plus 1 plus 1 plus 1 should have 2 plus infinity. In our example, we have 1 plus 1/2 plus 1/4 plus 1/8 plus and so on. If you like 1 using sigma notation, 1 over 2 to n starts at 0 equals to infinity. And that series will adapt to 2. We'll see in a couple of minutes why. So when we're talking about infinite series or infinite sums, or just sometimes we're going to call them series, we have two major possibilities for infinite series. They will either adapt to a finite number, or they will not adapt to a finite number. In first case, when we adapt to a finite number, we'll say they're convergent or converges. Convergent series. If infinite series does not adapt to a finite number, we'll say it is divergent. So in our first example, we get an example of divergent infinite series. Now, how are we going to address the situation to see if a series adapts to a finite number or not? In order to do that, we're going to introduce partial sum. So let's see what we're going to do. So we call our series S. Let's do S equals A0 plus A1 plus A2 plus A3 plus and so on. We're using sigma notation. AI, I from 1 to infinity. So what we'll do is we'll try to approximate the infinite series by something finite. So what we'll do is we'll try to approximate it by adding only one piece, then 2, then 3, then 4, and so on and so on. So we're going to introduce partial sums. So partial sums. Our first partial sum S0 is going to be just A0. Our second partial sum S1 is going to be A0 plus A1. S2 is going to be A0 plus A1 plus A2. S3 is going to be A0 plus A1 plus A2 plus A3. And in general, Sn will start at A0, and we can keep adding the terms till the last one is going to be An. So what we did is we come up with approximation to the infinite sum. So what will going to be happening is we'll say S is approximately equal to Sn when n is coefficient here is large. And what we'll do is we'll look at the pattern, what is happening with our partial sums, and that pattern, that limit of partial sums is going to be equal to S. So if I want to put that more formal way, I will say S equals limit of Sn when n is approaching infinity. So limit of partial sums is going to be limit of our series. So let's run down a couple of examples how we'll do that. Let's do a following example. We have a series 1 plus 3 plus 1 over 3 squared plus and so on, or using sigma notation 1 over 3 to n when n starts from 0 to infinity. And we want to know if that series converges or diverges, if it's convergent to what. So let's see how we're going to address that situation. what we want to do is we want to find a pattern, a formula for Sn, for nth partial sum. So Sn is 1 plus 1/3 plus 1 over 3 squared plus 1 over 3 to n. What we'll do with this guy, we're going to multiply it by 3. So 3 Sn is going to be equal 1 times 3 is 3, 1/3 times 3 is 1, 1 over 3 squared is 1 over 3 plus and so on, and the last one is going to be 1 over 3 to n minus 1. So what is going on here, if you look at this one, is if you look at this guy, that is going to be our Sn, which you see on top, with one missing term at the end. So what we concluded is 3Sn equals to 3 plus Sn minus 1 over 3 to n. And now we're going to solve it for Sn. So subtract Sn from both sides. So we have 2Sn equals to 3 minus 1 over 3 to n. So we get Sn equals to 3 minus 1 over 3 to n over 2. So we figure out the pattern formula for nth partial sum. And now to find whenever the series converges or diverges, what we'll do, we'll take the limit of this formula and see if we'll be able to succeed in taking that limit. So s equals to limit as n approaching infinity of Sn. That's how we decided to find the infinite series. We have our formula for partial nth sum. Now notice that when n is approaching infinity, 3 stays and 2 stays. They're not changing. And 3 to infinity is infinity, 1 over infinity is 0. So our answer is going to be 3 halves. So let's say the series is converges to 3 halves. Our next example is the following series, which is 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1 minus 1 and so on. For sigma notation, negative 1 to n, and from 0 to infinity. Down the road, we're going to be calling such series alternating series. So let's see if that series converges or diverges. In order to figure out that, we need to find a formula for what is going to be partial sum and partial sum. Let's figure out what's going on. So for example, S0 is negative 1 to the 0 is 1. S1 is going to be 1 minus 1 is 0. S2 is going to be 1 minus 1 plus 1 is going to be 1. S3 is going to be 1 minus 1 plus 1 minus 1 is going to be 0. So what you notice is, we kind of already notice a pattern. So partial sums are going to be oscillating between 1 and 0. 1 then 0, 1 then 0, 1 then 0, 1 then 0. And if you try to take the limit of that pattern 1, 0, 1, 0, 1, 0, that limit of that sequence is not going to be default, that this series